Hello, everyone. Ani Bosho. My name is Dr. Rebecca Pollock. You can call me Becky, and I'm the Executive Director here at the Georgian Bay MNIDOO GAMII BIOSPHER. I'm joined by Katrina Krievins, our Aquatic Conservation Programs Coordinator, and she and I have the great pleasure of presenting our State of the Bay Ecosystem Health Report program to you this evening, as well as some of the upcoming themes for our next report card, which is coming out early next summer. So thanks for taking the time. To begin, though, I want to acknowledge that we are situated in Anishinaabek territory that spans much of the Great Lakes, and that this biosphere region lies within the Robinson-Huron Treaty of 1850, as well as the Williams Treaties of 1923 to the south. And I'm joining you this evening from Parry Sound. I'm very grateful to the Indigenous communities of Wasauksing and First Nation and Shawanaga First Nation, particularly because my ancestry only goes back a few generations, and so I've inherited their incredible caretaking of this place. I'm also very grateful that members of these communities have been generous in sharing their knowledge and their teachings with myself and my organization. So miigwech. Thanks, Katrina. So we will be speaking this evening about an ecologically significant landscape that you must be familiar with, and that is the UNESCO Biosphere region designated here in 2004. And in our presentation, we're going to do several things. First, we'd like to give an overview of the State of the Bay program, as I mentioned, and then we're going to look briefly at the environmental legacy of colonization here in Eastern Georgian Bay. I'll then turn it over to Katrina, who will really focus on the science behind the State of the Bay report card and look at some of the indicators and themes that we're using in our next report. We're going to end by having a little discussion about a new approach that we're taking, and that is by integrating science with Indigenous knowledges, a really important new direction for us. So Indigenous perspectives to guide our work are extremely important, not only because we're a UNESCO site and we're committed to the United Nations Declaration on the Rights of Indigenous Peoples, but it's also understanding our responsibilities in Canada to reconciliation and to working against racism and continued colonization practices. And so one of the big changes for us was that we renamed our organization from Georgian Bay Biosphere Reserve to Georgian Bay MNIDOO GAMII Biosphere in 2020. And MNIDOO GAMII is one of the traditional Anishinaabek names for Georgian Bay, or Spirit Lake. And that was a recognition and recommendation that came forward from our Cultural Advisory Committee. One of the ways we put our reconciliation into action is through supporting Indigenous youth. Here's the Georgian Bay Anishinaabek Youth Group, who built this beautiful birch bark canoe in 2019. And so throughout our work, we try to honor the spirit of the water. So while this region is known as the 30,000 Islands and one of these beautiful 19 biosphere sites in Canada, one of over 700 biospheres worldwide, it's not just a region, it's also a growing and dynamic charitable organization based in Parry Sound. And this past summer, we had a staff team of 35 from different fields such as education, climate and energy, culture, researchers, and we're just so excited about the impact that we're having in this region. It's really an honor to do this work. So thank you for your support along the way. Our biosphere region is over 340,000 hectares. It takes in 8 major rivers, 6 provincial and 1 national parks, 16 conservation reserves on Crown or treaty lands, and it also includes a new protected area, an Indigenous protected area of Shawanaga Island. There's dozens of properties that have protection through the Georgian Bay Land Trust, and so that makes the percentage of protected areas quite high. In my view, when I look at the Great Lakes and the Ontario region, Georgian Bay is like a series of stepping stones that creates a major contiguous or corridor, of land and water for species in this part of Ontario. And because of its archipelago, it hasn't had the same pressures of other areas that have been open to roads. And so the Great Lakes have been described as the center of Turtle Island, the heartbeat that is providing clean water for all of creation. It's a good perspective. And while Georgian Bay, to many of us, feels like wilderness and does not have the same development pressures or agricultural pressures as urban areas, it faces virtually all of the same pressures when it comes to the cumulative stresses of urbanization, the invasive species problem, and climate change. And so when we look from this perspective, it can be overwhelming at times, but fortunately there are dozens of research agencies and management plans in place to help us respond to those pressures, not just track them, but manage them. So the State of the Great Lakes report is the result of the 1978 Great Lakes Water Quality Agreement that was updated as early as 2012. And it continues to provide this really high quality framework for coordinated monitoring on key indicators, such as drinking water, toxic chemicals, edible fish consumption, and groundwater. And so this is a regional and binational framework, Canada-US, that directly informs the health of all the Great Lakes, our Lake Huron, Georgian Bay, and then it also can help us shape our meaningful indicators that will then report our results right back up to that scale. So we are focused on local changes here in Georgian Bay, but it does feed into these higher frameworks. We also are working within the Lake Huron Lake-Wide Action and Management Plan. It's another guiding document at the Lake Huron Georgian Bay level that responds to these objectives for a healthy lake. And so on the whole, you know, the most recent results are finding that Lake Huron is in fair condition, which is to say some things are in quite good condition, some are fair, and invasive species gets a red mark there as they continue to really change the entire ecosystem as we've known it. One of our fish biologists, Runas Laskauskas, said, if you brought a fisherman here from 200 years ago, they simply wouldn't recognize what they're catching. Between the stocked species of salmons and others and the invasive species, it's just a whole new ecosystem in some respects. So when we think about Georgian Bay Biosphere and when it was formed in 2004, many people started asking, well, what is the state of Georgian Bay? You know, as children like to ask, is it drinkable, swimmable, fishable? And so we know that Eastern Georgian Bay has these unique ecosystem dynamics, including coastal wetlands, its extensive island archipelago, and it also has a really interesting dynamic between near-shore areas, which is sort of one set of dynamics, and the outer islands and deep water ecosystem. And they function quite differently. And so we needed to take a new approach. We also want to recognize that our area is home to over 50 species at risk, including this globally unique eastern fox snake, which really should be our mascot. It's very unique to Georgian Bay. And the story of the state of the Bay really starts in 2005 because we needed to go out really annually to stakeholders as we started shaping our mandate and ask research partners to help us understand how Georgian Bay is changing. We wanted them to help us assess the needs for science and monitoring because that is part of every UNESCO Biospheres mandate. And we knew there was already a network of scientists and agencies doing work on the Bay, along with conservation organizations and citizen scientists that were out testing water quality. But when we brought them all together to figure out who was doing what and what were the priorities, we were hearing from scientists that they didn't have enough resources to really communicate the results of their work. They couldn't communicate to the public or to decision makers in the way they wanted. And so they asked Georgian Bay Biosphere for help in translating their science into action. And that's really where it started. So annually, we held a meeting at Kilbear Provincial Park with stakeholders, and it just grew and grew and grew. And by 2009-10, we knew that we wanted our first State of the Bay report. We certainly couldn't do this without the partners mentioned. We rely on them, including federal, provincial agencies, conservation organizations, and First Nations, all of whom are doing their own ecosystem monitoring and have a lot to contribute from their perspectives on water quality, wetlands, fisheries, habitats. And so Katrina will speak to some of the research and data that each of them has shared with us in order to help see trends. So we really are grateful for their participation. Then State of the Bay was born. We were able to issue the first public magazine and technical report in 2013 with the help of an Ontario Trillium grant. And another 5 years later, we issued one in 2018. You may recognize these covers. And we're delighted to say that next year we will be issuing the 2023 report, but who knows what that looks like. Our goal is still to translate that science into action and to work across silos and single disciplines to kind of create a coastal research network. We're always trying to understand, take the pulse and the health of the ecosystem using different indicators, but it also helps us figure out where are the gaps in knowledge, where aren't we confident, or where are there changes that we're seeing that we can't yet truly explain. And so while our State of the Bay report card was loosely based on this idea of a watershed report card, we needed to heavily adapt our model because of this unique archipelago nature. We were looking at models in Sweden at the time, looking at what they were doing. But ultimately, with the help of these partners, as well as the Muskoka Watershed Council, our closest neighbor, we were able to design something that we felt strongly about to talk about the health of our area. So every report that we issue is a public magazine, but it is backed by a technical report, sometimes 200 or more pages, that's reviewed by experts in their fields. And so we have an expert advisory committee that sits with us throughout the year, and we can go to them with questions, and also they review the final chapters. Then it's taken and translated into a magazine. In the past, we've distributed 25,000 copies, and we know that we reach over 100,000 people, which is just so great. And so in addition to that, of course, we find that face-to-face interaction and learning is the best. We offer online articles and blogs, social media campaigns. We do a lot with schools, and with younger grades, we get them outside with the biology curriculum. We do teach students about the energy levels and trophic levels. We look at the food web and benthic invertebrates, and we get a lot of excitement about that from students. And so we are planning another community conference for State of the Bay. We don't know when that will be, but it is a really good way to bring together concerned members of the public with scientists, researchers, Indigenous project managers, and other groups. And so the main message is State of the Bay is not just a magazine, it's a long-term program for stewardship. And many of the important themes in our work are going to be presented just in a moment by Katrina. To give you a snapshot of our science-based communications, I wanted to show you this next picture of the Children's Water Festival. And it is an annual event. It's been running for over 10 years at Gilbert Park. And it's run by Parry Sound High School students who they themselves took the festival when they were in grade 5. So there's a legacy piece here where they organize it for 150 grade 5 students. And so this is the way we focus on future generations and helping them keep Georgian Bay healthy. But at the same time, we really have to realize that one of the reasons we even need a State of the Bay report is because of the legacy of colonization here. And so if I can just reflect for a moment on the colonization and settlement history around Parry Sound, and just mention really how much intense pressure it's put on nature, including our forest habitats, the rivers and lake systems, and the aquatic ecosystem out in the bay. It's been an absolutely central port community in the development of Canada, and it's been instrumental in the railway system, as anyone will know who's visited. And so here in both photos, we can see railway bridges and the pedestrian overpass on the Seguin River, or what would be known in Anishinaabek as the Ziguan River, or spring fast-flowing river. Thanks. And so both nature and culture have been colonized since the 1600s when Champlain first came. Indigenous cultures were dislocated due to the assimilation policies under the British Crown and later of Canada. And at its darkest point, there was just systematic destruction of culture. This has been considered by the United Nations as genocide, which really threatened and unraveled the knowledge systems of the original caretakers. The photo on the left of the boys with a pony on Wissahickon has no date on it from the archives, but the one in the middle is dated 1928 and shows some of the living conditions at that time. And on the right is the memorial to Wissahickon children taken through the residential school system, the 60s scoop, and early children's aid societies that robbed children of their family connections, their language, their culture, and identity. And this trauma is part of Georgian Bay's story, and it's part of my story. I acknowledge it as part of my settler ancestry. Moving into the 1800s, we had logging operations taking root and expanding incredibly quickly. Parry Sound was an industrial center for the whole Great Lakes, and as vast timber was cut down in the winter and flowed down rivers into the harbors and towed into sawmills like this one, the Conger mill, which employed 2,000 mill workers at the time and another 4,000 lumberjacks in the forests. So it shows the demand for lumber, first exported for shipbuilding and then fueling all the early wars. It was also used for the creation of our first cities, including, we can find Parry Sound timber in the Parliament buildings in Ottawa. All of this drove the creation and construction of the Canadian National Railway systems, helping to ship grain from the west to feed the population in the east. And changes in Georgian Bay waters were similarly wrought by a resource economy and commercial fishery that at its peak in 1880 saw over 2.5 million tons of lake trout extracted. I can't get over this fact, the 2.5 million tons in 1880. Commercial fishing for sturgeon, whitefish, herring, pickerel, and many other species had a cumulative effect, so weakening populations of fish and making them more vulnerable when the St. Lawrence Seaway was opened in 1959. As we know, ships carrying ballast water were also carrying invasive species, such as the sea lamprey, this parasitic eel-like fish. And then later in the 1980s, in my generation, these zebra mussels arrived that would simply wreak havoc on the ecosystem. Little did we know then what we know now. The changes in Georgian Bay continued apace with industrialization, and Parry Sound saw years of coal smelters, crude oil storage tanks, chemicals and tailing ponds from munitions plants that operated during both world wars. And there was even an oil spill in 1950 that spilled 2 million gallons of fuel oil into this harbor. Much of it was pumped right away into rail cars that were standing by, but then hundreds of workers were brought in by Ottawa to clean up local beaches. When I walk on the beaches in Nobel, I can still see these hardened lumps of what must have been oil congealed and hardened over time. That's 70 years ago. So this is all part of our legacy. And the reason I say this tonight is that our State of the Bay program is a powerful way to confront this legacy of colonization. We need to reconcile with the land and with each other now. And so with the State of the Bay, the research is trying to tell us, are things getting better? Are they getting worse? Why? And what can we do about it? What can be done? We've seen top predator species like the lake trout, come to the brink of extirpation. We've seen mass species die-offs like this alewife collapse. And over the past 200 years, we've just witnessed unprecedented changes. And so while this is not really a positive legacy in this point of the story, I really do have hope. I believe in the work that we're doing. And I also see climate action, youth engagement, and community stewardship like never before. So now I'd like to turn it over to Katrina to summarize some of the conditions in Eastern Georgian Bay. Thanks, Katrina.
All right. I'm just going to see if I can get my camera switched over here. All right. I'm not sure if folks can, okay, there we go. All right, well, I'm just going to tuck that out of the way for now. Okay, great. So now that Becky has provided you with the context for State of the Bay, I'd like to take some time to explore the indicators and some of the key findings from the 2018 report. Now, there is so much that we could talk about, so I'm only going to focus on one or two main messages for each indicator and encourage those who are interested in learning more to visit stateofthebay.ca. So water quality is our first indicator that we talk about in State of the Bay, and when reporting on water quality, we focus in on total phosphorus. Phosphorus is the nutrient that controls plant and algae growth in the water. Too little phosphorus and there aren't enough nutrients to support the rest of the food web. Too much phosphorus and you can end up with nuisance or even harmful algae blooms like those experienced in Sturgeon Bay in the past. So ideally, you want a balance between the two to support a healthy ecosystem. In Georgian Bay, total phosphorus levels vary depending on whether you're looking at shallower areas close to shore or the deep offshore waters. Generally, in the offshore deep waters of Georgian Bay, total phosphorus levels have been naturally low, around 5 micrograms per liter. And in shallower protected bays or near wetlands, phosphorus levels can be much higher, which supports a more diverse food web and is great for fish habitat. Now, looking at the figure on the left, you can see that generally areas closer to shore and inland have total phosphorus levels in the 5 to 10 or 10 to 20 range. And there's even a few spots over 20 micrograms per liter where we might be concerned about nuisance algae. Further out in the deep offshore waters, we see mainly light blue dots representing 0 to 3 micrograms per liter. And as the figure on the right shows, offshore concentrations of total phosphorus abruptly declined around the year 2000 and have decreased to approximately 2 micrograms per liter. And this might not seem like much, going from roughly 5 micrograms per liter to 2, but for the first time in recorded history, total phosphorus concentrations in the bay are as low as those of Lake Superior, which represents an unprecedented low level of phosphorus in the bay, to the point where scientists have described the offshore waters as a biological desert. The next indicator in State of the Bay is relates to the lower food web, and this is really the foundation of the entire food web. Without it, nothing else could survive. Not minnows, not bass, not lake trout, none of them. And we describe the lower food web in terms of phytoplankton, zooplankton, and benthic invertebrates. So let's start with phytoplankton. Phytoplankton are microscopic aquatic plants, and as you can see from the images on the right, they can be quite intricate and really quite beautiful, actually. Like plants on land, they have chlorophyll to capture sunlight, and they use photosynthesis to turn that into chemical energy. Now, there's a lot going on in the graph on the left, but the main takeaway here is the huge decline in spring phytoplankton biovolume in Lake Huron starting around 2003. Following that 2003 mark, there's variability year to year, but really nowhere near the biovolume prior to 2003. Similarly, at a more local scale, the figure on the right was produced by Severn Sound Environmental Association with their monitoring data, and it shows that same decline in phytoplankton biovolume. These points that you see here in the legend, P1, P4, M1, these are all long-term monitoring stations in Severn Sound, and they're each showing significant declining trends in annual phytoplankton biovolume. Next in the lower food web is zooplankton. Zooplankton are tiny animals that live in the water column, some of which you can actually see with the naked eye if you look close enough. And on the right here, we have a number of examples, including the invasive spiny water flea, which is competing with our native zooplankton for the same resources and causing troubles in that way. Unlike phytoplankton that get their energy from the sun, zooplankton are consumers, meaning they eat phytoplankton or other zooplankton for their energy. And because of this simple fact, if the phytoplankton community in a lake isn't doing great, you can imagine the zooplankton that feed on them probably aren't doing so hot either. Again, there's a lot of information on this graph on the left, but the key takeaway again is that dramatic decline in biomass around 2003, and the fact that those numbers have stayed fairly consistently low going forward. Finally, we come to benthic invertebrates. And benthic invertebrates are aquatic insects that spend all or part of their life cycle living at the bottom of the lake. They're also consumers like zooplankton. They eat phyto, zooplankton, and other invertebrates. And the first message that I want to get across when talking about benthic invertebrates is the almost complete disappearance of diparrhea from Lake Huron. And if you're wondering what the heck is diparrhea, you're looking at one right here on the screen on the right. So these critters were once the most abundant benthic invertebrate in the cold offshore regions of the lake and were a key component of the food web. Most fish in Georgian Bay fed on these organisms at some point in their life cycle, and with really good reason. These critters are super energy dense. They're a really great food source. Now, the figure on the left shows how diparrhea have been disappearing from the lake. Really simply, the dark colors mean greater density in an area. And so you can see that those once dark colors in 2000 progressively get lighter throughout the years. And although this figure shows only the main basin of Lake Huron, this same trend was seen in the bay. The figure just wasn't created for the bay, but that exact same trend was seen in the bay. The diparrhea population crash happened around the same time as the rise of invasive mussels, but as convenient as that explanation would be, the connection between the two is not yet fully understood, and research on that topic is still continuing. But regardless of the cause, this is definitely a major loss of a food source for many fish species and certainly has implications for the entire food web. The other benthic invertebrate story that I want to talk about is related to zebra and quagga mussels. So while many people may not have been previously familiar with diparrhea, I'm guessing everyone here has heard about invasive zebra and quagga mussels. Zebra mussels, as Becky mentioned earlier, became established in Lake Huron. They were first introduced in the 80s, but they became established in the early 1990s. Their abundance peaked around 2003 in the main basin and then around 2007 in the bay. From there, quagga mussels took over and took things one step further. So while zebra mussels were restricted to shallower water, quagga mussels are also able to invade areas deeper than 50 meters, where zebra mussels had rarely been found. And that's shown pretty clearly here in the series of figures. So we really start to see in the bottom figure how quagga mussels are taking over and getting into those deep, deep areas of the main basin in the case of this figure, but the same has been happening as well in Georgian Bay. Getting into those deep waters where zebra mussels were never able to make it and survive before. And the reason this invasion is so troubling is because these drycenid mussels, as they're referred to collectively, are extremely efficient filter feeders. They take water in and filter out the plankton, reducing what's available for other organisms to eat, which ultimately alters the food web. So this photo here shows how effectively water is filtered by the mussels in only 10 minutes. So there's two jugs here, same water taken from a river, and on the sort of right panel of the figure, you can see the jug that has the mussels in it. After 10 minutes, how clear that water is from the mussels removing all of the plankton from that water. Okay, with all of these changes to the lower food web, I'm sure you're starting to think about how this might be affecting fish populations moving up the food web. But remember, it's not only changes to the lower food web that fish communities in Georgian Bay have had to contend with, and Becky talked about this already a bit. There's been considerable fishing pressure, there's been alterations to habitat, warming water temperatures, and a whole host of other stressors that fish have had to deal with. Now, we're not going to cover all the species that are shown here, but we thought that this artwork was just too beautiful not to share. So some of the species we are going to talk about that are shown here on the screen would be pike, lake trout, and pickerel or walleye, along with some others that aren't pictured here. But let's start off with talking about prey fish. Prey fish are the small fish that get eaten by the predator fish and that make up really the majority of fish in the Great Lakes food web. Similar to the other graphs that we've seen so far, prey fish biomass in Lake Huron starts falling off in the early 2000s and remains relatively low. You can also see a shift in the dominant species simply by looking at the colors that are or are not present. This graph is for Lake Huron as a whole, and each basin is going to differ. Each basin being either the main basin, Georgian Bay, or the North Channel will differ in terms of which species are dominant year to year. The pie chart on this slide shows which species are dominant specifically in the year 2019. It's also worth noting that both alewife and rainbow smelt are actually introduced species, which not everyone is aware of. They've been with us for quite some time, so many people just think that they are native species to this to Georgian Bay, but they actually are not. So let's remember now quickly that these fish are the food source for all of our top predators. So we've got to start wondering, how might our top predators be coping with these changes? So one of the specific fish species that we hone in on in State of the Bay is smallmouth bass. And they're not a species that's targeted in the commercial fishery or has been in the past. So we don't have really long records on their abundance like we do for some other species. But we do know that they're very abundant in Eastern Georgian Bay today. And interestingly, smallmouth bass is one native species that may be benefiting from some of the changes happening in the bay. For example, smallmouth bass have started eating the extremely prolific invasive brown goby, and in doing so are growing faster and growing bigger, which is good news if you're a smallmouth bass angler. They may also be able to expand their range in some places because of warming water temperatures. They are a warm water species, and with more areas of the bay warming up, they can essentially live in more places now. If you ask anyone who fishes in Eastern Georgian Bay, they'll probably tell you that if you know what habitat to fish in, it isn't overly difficult to catch a pike. They're certainly around in good numbers, but not nearly to the extent that they were before the alteration of shorelines and wetlands for development purposes. Pike rely on coastal wetlands for spawning and nursery habitat as well, and even water level changes in the bay can wreak havoc on that habitat. And that's shown a bit here in this graph for Severn Sound. You'll see the black bars are northern pike catch per unit effort, or how many fish are caught each time the lake unit sets a net out. And the sort of navy blue dots and lines are showing the Lake Huron water level. The dashed blue line, excuse me, is the average Lake Huron water level over that entire time period. But you can see where Lake Huron water level drops and stays pretty consistently low, so too does northern pike catch per unit effort. So there's definitely a relationship there between the two. All right, muskie. The nearshore waters of Eastern Georgian Bay and the North Channel support the largest contiguous distribution of muskie populations in the Great Lakes. And as with smallmouth bass, we don't have a great idea of what muskie populations looked like 50 or 100 years ago, but provincial biologists have been surveying populations regularly in Eastern Georgian Bay since about 1996. And their surveys confirm widespread distribution and presence of mature muskie throughout the coast. And this is really great news. And it's obviously the reason muskie anglers flock to this region. The photos here show some extremely healthy muskie being pulled out of the bay. It is important to note, though, that for muskie populations to remain self-sustaining, preserving coastal wetlands is a priority because just like pike, muskie rely on these habitats for spawning and nursery habitat. Walleye or pickerel in Georgian Bay have been hit with multiple stressors over the past couple centuries. Overexploitation, human alteration of spawning rivers, the introduction of invasive species, the list goes on. Walleye populations in Eastern Georgian Bay are likely only a small fraction of what they used to be, and despite many efforts to rehabilitate them, there's been fairly limited success in this part of the bay. One exception, however, is the Shawaniga River spawning population, which is doing better than most in Eastern Georgian Bay. Shawaniga First Nation has operated a walleye hatchery for decades now, and the eggs and milk that are used in the operation are collected from fish spawning in the Shawaniga River. Once the eggs hatch and the fry are ready, they're released back into their home waters. And finally, lake trout is the last species that we cover. Most lake trout populations in Lake Huron collapsed around the mid-20th century, which Becky mentioned as well. And this was a result of sea lamprey invasion, overexploitation, and the decline of the deepwater cisco, which was their major food source. Efforts to rehabilitate populations started in 1969, and this included sea lamprey controls, pretty intensive stocking efforts, fish sanctuaries, and strict fishing restrictions or regulations. Now, the good news story is that the Parry Sound lake trout population is actually considered fully rehabilitated. So that is really fantastic news. Unfortunately, most other populations haven't had the same success, and with reduced productivity in the offshore waters and other ecosystem changes, the prospects for rehabilitation are uncertain at best. And just quickly, the maps that are shown here on the screen are the 3 lake trout rehabilitation zones that fall sort of within the Eastern Georgian Bay area. So you'll see the Parry Sound, LTRZ here, if you can see my cursor, so it's on the left. In the center, there's the Limestone Islands, LTRZ, just to the west of the Parry Sound one. And then a little bit further south along the eastern coast, we have the Watcher Islands, LTRZ. So Parry Sound doing well, the other 2 less so. All right, moving on to our next indicator, coastal wetlands. Eastern Georgian Bay boasts some of the highest quality coastal wetlands in the Great Lakes, which is great news because these ecosystems are absolute powerhouses in terms of ecosystem services and supporting biodiversity. Relative to other parts of the Great Lakes, we've been fortunate that we haven't seen as much wetland dredging, filling, and conversion. Now, this is certainly not to say that coastal wetlands in Eastern Georgian Bay don't face serious threats. We know they do. Shoreline development, invasive species, even prolonged high or low water levels can negatively impact coastal wetlands, as we talked about with northern pike. So a big question going forward is, what does a changing climate mean for Eastern Georgian Bay's coastal wetlands and all the species that rely on them? And there's recent work by Environment and Climate Change Canada that explores these questions that we'll be looking to summarize in the 2023 report. Landscape biodiversity is next. The Canadian Wildlife Service undertook a modeling and mapping project that provides useful information on 2 measures related to landscape biodiversity. High value biodiversity areas that you see on the map on the left, and human footprint analysis on the other map. Green areas on that first map are places that contain at least 2 high value habitats such as forests, grasslands, and wetlands, and contain important habitat for migratory birds and species at risk. The other map shows a human footprint analysis. High human influence, shown in red, contrasts areas with low human influence, shown in green. And as expected, these areas of high influence occur along transportation routes and around areas with large populations like Parry Sound and Honey Harbor. But by combining these two metrics, we can identify areas of high biological and habitat diversity that are also subject to a lot of human disturbance, and then consider these areas a priority for conservation. Okay, so moving on to climate change. There are a variety of ways to track trends related to climate change, and we've chosen to focus on summer surface water temperature and maximum annual ice cover for a number of reasons. One of those being that there is consistent and relatively long-term data that is easily accessible. So looking at this chart on the screen here, the green and blue dots are temperatures taken at 2 buoys in the open waters of Lake Huron. And the chart is showing us a close to 1 degree Celsius increase in water temperature each decade. Now, this is one of these things that doesn't sound so bad at first, but if we just take a second to think about the change over 1 century, that's an increase of around 10 degrees Celsius. It's entirely likely that there are species currently in Lake Huron that simply won't be able to deal with that rate of increase. And on the flip side, invasive species and new invaders that might thrive because of it. Turning now to ice cover, the figure on the left shows the percentage of peak or maximum annual ice cover for Lake Huron starting in 1973. And you'll notice that there's a whole lot of variation from year to year with some noticeable peaks and valleys. This is common for most climate-related data. Despite there being colder and warmer years with more or less ice cover, there's a clear long-term warming trend which appears as a declining trend in ice cover. Less ice cover on the bay will not only have significant impacts on fish and wildlife, but also on the economy of this region. And as an ice fisher myself, I find this information extremely concerning. So that brings us to the end of the indicators. Of course, we really just skimmed the very surface here. So I do encourage you to read up on the details of these ecosystem dynamics in the 2018 report. You can find both the magazine and background report at stateofthebay.ca. And we're now hard at work collating information from our partners to provide updates on these indicators. As Becky mentioned, the 2023 report is on its way. And while the ecosystem changes and challenges I've mentioned can seem pretty daunting, it is really inspiring and uplifting to see the incredible work of our partners on the coast. And we do really look forward to sharing their stories in our next report. As Becky already touched on, State of the Bay would not be possible without the efforts of all of our partners, and we're extremely grateful to be able to work with them to get their stories out to a wide audience. And I'll turn it back over to Becky.
Thank you, Katrina. So grateful for the science perspectives that you bring. As a social scientist, I'm always fascinated by these stories and the search for knowledge that many of these individual researchers and research teams are pursuing. So I'd like to end the presentation with a couple of slides about our new approach for State of the Bay. In fact, it's a new approach for all our work, and that is about the incorporation and respect for Indigenous knowledges, because we need a new approach to conservation science, one that doesn't ignore Indigenous knowledges, or one that privileges Western science or continues to do so. So what we've done is over the past decade, we've slowly been learning about our cultural heritage in Anishinaabek territory in terms of how we can learn respectfully and listen and share. And so we've been able to support Indigenous-led research. We've been able to hire Indigenous youth. And we're learning all the time, learning about what it is to be Anishinaabek, learning from their values, the stories that they wish to tell, and their ways of caretaking, because I believe it's really critical for our future in this place to understand those values. This is an approach that's sweeping across Canada. Cultural ways of knowing are being woven with science. And as Elder Albert Marshall from the Mi'kmaq community has stated, we need to learn to see from one eye with the strengths of Indigenous knowledges and ways of knowing, and learn to see from the other eye with the strengths of mainstream Western or Eurocentric knowledges and ways of knowing. But most importantly, learn to see with both eyes together for the benefit of all. He talks about this because these knowledge systems are complementary. They bring to each other what neither can do alone. And so this is the approach that we're taking for our next State of the Bay report. And it's also the one we're using right now with partners in our Momwe Angiakiziwin project for species at risk. All of the little turtle eggs that have been rescued have been guided through this perspective. And every year we do more training and learning, and we take the time to ensure that Western science is balanced and integrated. And so just to go into this a little bit more, in order to really use two-eyed seeing for State of the Bay, we're currently involved in a series of discussions with our Cultural Advisory Circle. And that includes Indigenous youth and elders and other members of the community in order to hear their vision of how a State of the Bay report can communicate Anishinaabek worldviews, values, and teachings. And at one of our last meetings, we heard that the medicine wheel could be used as a powerful teaching tool to convey not only resource use and harvest cycles of fishing, berry picking, and hunting that we think of, but also some of the teachings associated with the moon cycles, the clan responsibilities, and fundamental concepts such as caretaking and reciprocity. And it is these teachings that can inform our approaches to ecosystem management. It helps our understanding of our own roles and how things are connected. And so we're struggling right now, but piecing this together with support in order to find a way to tell both the science story and the Anishinaabek story. One of the things that we'll also do is use Anishinaabe Mowin, the Ojibwe language, because that will further our understanding, because language contains relationships with the natural world that just don't exist in English. So this is a map created by Dr. Brian McGinnis of Wasauksing. He's a member of the Wasauksing community and is now a professor in Michigan. And it shows the traditional place names that contain these meanings and stories about how people interacted with nature and these very specific places. So there's profound insights to be gained from Indigenous cultures who've been living here since time immemorial. As people lived off the land, of course, observed these changes day to day and year to year and century to century. This is invaluable knowledge for future generations. To give you one example of two-eyed seeing is how we can develop a deeper understanding of the role of fire ecology and the role of fire keeping in Anishinaabe culture. The Parry Sound 33 fire was the largest in well over 100 years, and fire suppression in some areas that we think of as fire management actually led to the conditions that increase the vulnerability and the chance of having a massive fire. And so we're hearing now from scholars and Indigenous knowledge keepers about the role of fire management. Everything was managed through fire, from berry crops to bear populations, as well as a number of the life cycles of plants and medicines that really benefit from renewal by fire. So these are the kinds of conversations that have started. Another example is our shared understanding of fisheries restoration, as Katrina has described, and some of the walleye recovery projects, as well as the sturgeon monitoring. Community caretaking that's based on this ethic of reciprocity, of what our role is in terms of caring for the land and waters that in fact care for us, that reciprocity. It, I think, is a model for us to learn and follow. And so one of the things that we're discussing every day is how do we challenge ourselves to think about our role in nature rather than the colonial domination of nature, but working with it and working with humility. Maybe this is a key to our future survival and our future sustainability. So a new conservation model will actually weave reconciliation into our work as we work with First Nation partners. We will see this in the work of our reptiles as we, teach each other what turtles have to tell us. We're very grateful to knowledge keepers like Cheryl, who's been sharing some of her teachings and has been giving ceremony to baby turtles to start their lifelong journey as they're released from our turtle incubation lab back into the wetlands near where they were born. And by honoring these protocols, these cultural protocols, we're teaching the mutual values of science on the one hand and caretaking on the other. And so I want to thank you for joining us. We live in an uncertain future with a changing ecosystem, but we've equipped our community with scientific understanding and awareness of Indigenous values. And so despite these increasing pressures on the landscape, we really feel that the state of the Bay is more important than ever. And so as a charity, we're always seeking ways to support this program now and for decades to come. So you've already supported us by joining the presentation. You can also be invited here to subscribe to our e-newsletter, follow us on social media, become a member, or make a donation. We also have sponsorships available in the next State of the Bay magazine. If you're a business or an organization who's interested, we'll send you that package. And attend events, especially next summer when we're doing these launch events and we have new stories to tell. So thanks for spreading the word. We really are thankful for your support. And we know that you're dedicated to coastal conservation now and for future generations. Miigwech.